We are moving on to 8.1. There is no chapter 7 that we're going to do in ALEKS. So chapter 8 deals with trigonometry. Do you guys remember the mnemonic for sine, cosine, and tangent? So the sine, bring this over. The sine of angle theta is the opposite side divided by the hypotenuse. The cosine of theta is the adjacent side divided by the hypotenuse. And the tangent of theta is the opposite side divided by the adjacent side. When we say opposite, what do we mean? The side across from the angle. And a triangle has three sides, but we never choose the right angle to be theta. Now, we're actually we can do that, but you haven't learned enough trig to know how to do that yet. So for simple right triangle trig, angle C cannot be theta. So if I choose angle B, and I call that theta, which side is opposite B? 12. And which side is adjacent to B? 5. And then the longest side is always called the hypotenuse. So this right here is the hypotenuse. Do you guys know what hypotenuse means? It's a Greek word. It translates roughly into an occupied toilet on a mountain. No? Nobody? Oh, we got one. Hypotenuse. Oh man, that was terrible. That was terrible. So, what's the mnemonic we use to remember SOHCAHTOA? Oops, I mean to remember sine, cosine, and tangent. It's SOHCAHTOA. How do you remember the spelling of SOHCAHTOA? When I was in school, there was some story about an Indian chief named SOHCAHTOA. I can never remember it. But here's how I remember it. Some old hippie caught another hippie tripping on acid. Now you'll never forget it. Hey, I got some laughs on that one. All right. So this problem is asking, what is the cosine of A? So if A is the angle we're dealing with, and cosine is adjacent over hypotenuse, what is the cosine of A? 12 over 13. So if this is the angle I'm dealing with, then adjacent divided by hypotenuse is going to be 12 over 13. All right, what about the tangent of A? 5/12. So tangent is O over A would be 5 over 12. And the sine of A? It would be 5 over 13. Okay. Do you want to see more of those? Everybody good with simple sine, cosine, and tangent? Okay. Let's go to the next one. So here it wants to know, what is the cosine of 88 degrees? Well, I need a calculator for that. And you need to make sure that your calculator is in degrees. There are two ways to measure angles. One is radians, one is degrees. And degrees make sense in the real world, like in the physical world, but they don't really make sense theoretically. Radians make no sense in the real world, but in the theoretical world, radians are far more useful. So if you have a scientific calculator, you have to make sure that you're in degrees. So there will be some button on there. I think on the screen it will say RAD or DEG. Make sure you're in DEG. And there's some mode button that you can switch between radians and degrees. If you have a graphing calculator, then you want to push mode, and then the third or fourth line down lets you choose between radians and degrees. You want to be in degrees. All right. So all we have to do here is the cosine of 88, and it gives us 0.03. Okay. So the tangent of 43, so tangent of 43 is 0.93, and the sine of 25 is 0.42. Now, what do those numbers mean? Well, I would say most math students don't understand what the sine of 25 is asking. Okay? So if I draw a right triangle, and this angle here is 25 degrees, and sine would be opposite divided by hypotenuse, what we're saying is the opposite divided by the hypotenuse is 42%. So what that's saying is, for every single triangle where this angle is 25 degrees, the length of the opposite side is 42% as long as the length of the hypotenuse. And that's true for all triangles that are similar to that. So if I drew a much smaller triangle that had the same angle, x divided by y is going to be 42%. If I drew a huge triangle and this angle was 25 degrees, then the opposite side divided by the hypotenuse would be 42%. So trig allows us to connect the angles of a triangle to the side lengths of the triangle. And they're all just ratios. So sine, cosine, and tangent, they compare one side to another side. And it's true for all triangles that have the same angles. So every single time you have a triangle with a 25-degree angle, then the opposite side to that angle will be 42% as long as the hypotenuse of that angle. And that's really all trig is. All right, let's go to the next one. So how do we use that information to solve a triangle? I need water. Here we have a triangle with a known angle, and we know that the hypotenuse is length 6, and the adjacent side is unknown, and we want to find how big the adjacent side is. So which trig ratio do I need to choose in this case? Cosine. So the cosine of 33 degrees is equal to x over 6. How do I solve for x? Multiply by 6, and I get x is simply 6 times cosine of 33. So 6 cosine of 33 gives me 5.03. Okay. All right, what if it was the other way? What if What if this was x and this was, say, 10? Then the problem would be the cosine of 33 is equal to 10 over x. How would you solve that? So I need to multiply this by x and then divide by the cosine of 33. So really the simpler way to do this is just to switch places with those. And we get x equals 10 over the cosine of 33. And every single right triangle problem like this will either be a multiply problem or a switch problem. Whether you're using sine, cosine, or tangent, every single problem will either be a multiply or a switch. Okay. So let's say this is 60 degrees. Let's say we had 15 and x. Which trig ratio am I going to choose? Sine, cosine, or tangent? So I know the opposite side and I'm looking for the adjacent side. So that would be tangent. The tangent of 60 is 15 over x. Is that a multiply or a switch problem? A switch problem. So I switch places with those. And we have 15 divided by the tangent of 60. And the answer is 8.6. Okay. Wow. Not sure how I did that, but that was cool. All right. Let's put the x here. What trig ratio would I use in this case? Sine. So the sine of 33 is x over 6. Is that a multiply or a switch? Multiply. So the answer is 6 sine of 33. Okay. All right. Same basic idea here, except instead of just looking for part of the triangle, I want everything. So they have given me one side and one of the base angles. So angle A is actually really easy to figure out. So what plus 44 is 90? So that would be 46. Okay. How would I find angle C? Or sorry, side C. What ratio would I set up to solve for side C? The cosine. So the cosine of 44 is 29 over C. Do I have to use the cosine? How else could I do it? If I switched angles, the sine of 46 is also 29 over C. And both of those are switch problems. So 29 divided by the cosine of 44. And that happens to be exactly the same thing as 29 divided by the sine of 46. And that will always be true. The sine of one of the base angles is always equivalent to the cosine of the other base angle every single time. Okay. I now have this as 40.3. How would I solve for b? I could do the tangent of 44 is b over 29, and that's a multiply problem. So 29 times the tangent of 44. Okay. Or I could also do the sine of 44, and that would be equal to b over 40.3, and that would be a multiply problem. So 40.3 times the sine of 44. How come those aren't exactly the same? Oh, I did the cosine. I'm sorry. Okay. You're both correct. Okay. So why are 28.0 and 27.99 not exactly the same thing? Because I used a rounded number. So this number is a rounded version of that. So you're welcome to use the sign in this case, but you would need to type in all of those numbers to make sure that we didn't have any sort of mistake. So when you're doing ALEKS and you're using a computed number for a future answer, don't round anything, or just avoid that number if you can. Okay. All right. Here we have a right triangle with two known sides, and we want to know what is the sine of theta. So the sine is going to be x over 17. How do we find the size of x? What formula are we going to use? Any idea? What's that? No. So the question says, if this is the angle I'm focusing on, what is the opposite side divided by the hypotenuse? So it doesn't want to know how big theta is. It wants to know how big sine of theta is. Pythagorean theorem. So 8 squared plus x squared equals 17 squared. 17 squared, what is it? 289. So we have 64 plus x squared equals 289. What do I do here? Subtract 64. So x squared equals 225. I take the square root and I get 15. So x equals 15. So I now know that x is 15. What is the sine of theta? So sine would be opposite over hypotenuse. So the answer is 15/17. Okay, let's do another one of those. All right. So we want to know the tangent of theta. Let's call that b. So 8 squared plus b squared equals 9 squared. 64 plus b squared equals 81. Subtract 64. B squared equals, what is that, 17? So b is the square root of 17. What would the tangent of theta equal? Well, tangent is opposite divided by adjacent. So we would get 8 over root 17. But we can't leave it like that. We're not allowed to leave square roots in the denominator. How do we fix that? We times it by root 17 over root 17. And the top becomes 8 root 17. And the bottom is just the square root of 17 squared, which is 17. So the tangent of that angle is 8 root 17 over 17. How many have we done? 1, 2, 3, 4, 5. We'll stop there. Okay, that is it for today. Get to work.